Hello friends, today we are going to discuss about the inverse of matrix. Okay, we see about 2 into 2 and 3 into 3 matrices. Okay, for an example, matrix A is defined by A, B, C, D. So we can get A inverse is equal to adjoint A over determinant of A. So what is adjoint A? It is the transpose of cofactors. Okay, so we will see how to find these cofactors. Okay, so I'm going to write as two columns like element and cofactor. So elements are A, B, C, D. So see, if we find the determinant, what we will do? Yes, AD minus BC. So cofactor of A is D, and that is plus, and cofactor of B is minus C. For C is minus B and D is plus A. Okay, so we can write the cofactors. Okay, so I'm going to write the cofactors. So cofactor of A is plus D and B is minus C. For C is minus B and for D is plus A. So this is the cofactor. So adjoint will be the transpose. So it would be A minus B minus C and D. So just see that. So A inverse would be this adjoint and the determinant, the ratio between them. So you can see that A and D would be in the same position and B and C would be in the same position, but their sign will be a negative one. So you can think like this also will be helpful for you to remember and do the questions. Okay, so let's talk about inverse of a 3 by 3 matrix. So I am writing a 3 by 3 matrix with ABC like this. Okay, so now I'm going to find about the adjoint. The adjoint is the cofactor, no? So we know how to do the cofactor when we do the expansion. So like that, for A1 we have to close the row and the column of A1 and write the except 4 elements like that. With A2, that B1 B3, and for A3 it's B1 B2 and C1 C2. For B1 that is A2 A3 and C2 C3, and for B2 it would be A1 A3 and C1 C3, and for B3 it's A1 A2 and C1 C2. For C1 it would be A2 A3 and B2 B3, and for that A1 A3 and B1 B3 for C2, and for C3 is A1 A2 and B1 B2. Okay, this is the cofactors and we have to find that with signs, no? So that is plus minus plus and minus plus minus, plus minus plus. Okay, so we have to find them and do that. So I'm going to write the multiplication of the first set of numbers will be P1, and for the second one is minus P2, and that one is P3, and the other one is minus P4, P5 and minus P6, P7 minus P8 and P9. Okay, so I am writing that as a elements with P. Okay, so cofactor of A1 is P1 and A2 is minus P2, like that. So adjoint A would be the transpose of these cofactors. So if we write, we will get the cofactor as, and we know how to find the determinant of a 3 by 3 matrix. So we can find the determinant and find the inverse. Okay, so let's go with the first question. The first question is about 2 by 2 matrix. So 5 minus 2, 7, 3. Okay, so at first I'm going to find the determinant of this matrix is 5 into minus 3 minus 7 into minus 2, and the adjoint is we have to interchange 5 and 3 minus 3, sorry, and we have to write the minus sign of 2 and 7, so plus 2 and minus 7. So if we multiply the determinant, that is minus 15 minus 14, so that is equals to 1 over minus 29, and we have to write the adjoint and simply multiply that. So 3 by 29 and minus 2 by 29, 7 by 29 and minus 5 by 29. This is our A inverse. Okay, to cross check whether you have gotten the correct answer or not, you can use this one. A into A inverse is an identical matrix. Okay, let's go with the question number 2. Okay, so A in A, matrix A is equal to minus 3, 5, 1 and minus 2. So A inverse is the determinant. So minus 3 into minus 2 is 6, minus 5 into 1 is 5. And I am interchanging A, D and minus sign of B and C. So minus 1 and minus 5. 6 minus 5 is 1. So the adjoint would become as the inverse. Okay. So question number 3. A is equal to 4, 3, 2 and 2. So A inverse is 4 into 2 is 8 minus 6 and 2 and 4 minus 3 and minus 2. So 8 minus 6 is 2. So half 2 minus 3 minus 2 and 4. So I'm going to multiply that. Half into 2 is 1, minus 3 by 2, minus 1 and minus 2. This is the inverse of this matrix. Okay, now we are going to practice for the 3 by 3 matrix. So this is our question. Matrix A is equal to minus 1, 2, 3, minus 2, 1, 4, 2, 1, 5. Okay, so this would not be complicated. Rather we find the adjoint A and the determinants clearly. So for that we have to find the adjoint of A and the determinant of A. So first I am going to find the adjoint. For that I am going to write the cofactors. So first I am going to write the cofactors. So cofactor for minus 1 is 1, 1 and 4, 5. And for minus 2 is 2, 3 and 1, 5. Okay, for that we have to just take the number and hide the row and column and write the rest of the numbers, so that the multiplication of those numbers are cofactors. So I'm going to writing now for 2, that is minus 2, 2 and 4, 5. For 1 it is minus 1, 2, 3 and 5. For 1 that is minus 1, minus 2, 3 and 4. Okay, for 3 I'm going to write the last row. 3, that is minus 2, minus 2, 2, 1, 1. And for 4 is minus 1, 2, 2, 1. And for 5 is minus 1, minus 2, 2 and 1. Okay. So now we have to put the signs in front of them. So I'm writing the signs. For the second one, minus, plus, minus and plus, minus, plus. Okay, so now I'm going to find the values of cofactors. So the first one is 1 and the second one is minus, so minus 7. For that one, 8 minus 3 is 5. Okay, so next minus 10 minus 8 is minus 18, that multiplied by minus is plus 18. Next one is 5 minus 5 minus 6, so that is 11 and minus 11, and minus 4 plus 6 is minus plus 2, and that would be minus 2. And the next one is minus 4, 5, and for the last one is 3. So this is the adjoint, sorry, this is the cofactor. And now I'm going to find the determinant of the 3 by 3 matrix using copying method. Okay, so you can do in either ways, like copying 2 columns or by expansion. So copying the 2 columns are very easy, and we can use this that very fast. So I'm do with that method. Just multiply the corners and add the 1 corners and subtract the addition of next 3 corners. Okay, so the first one is I'm done, and second one is I'm writing now minus 20, and the second corner would be minus 4, and the third one is plus 6. So minus 5 minus 6 and plus 16, that is equals to 5 minus minus 18, so that would be plus 18. So 5 plus 18 is 23. So yes, I'm going to write the inverse of A. So the adjoint, so we have to write the transpose of that one. So transpose would be yes, 1 minus 7, 5, and 18 minus 11 minus 2 and minus 4, 5, 3 over the determinant, that is 23. Okay, so we have to multiply that. So 1 over 23 would come like that. So yes, I'm writing them. 1 over 23, 18 over 23, minus 4 over 23, minus 7 over 23, minus 11 over 23, 5 over 23, 5 over 23 because they are same, and minus 2 over 23 and 3 over 23. Okay, you can use this by using your scientific calculator, but you cannot find it as a fraction. You will find it as a decimal numbers. So that would be a bit confusing. Okay, let's go with the final question. Question number 2 for the 3 by 3 matrices. My matrix is 3 0 2, 3 minus 4 minus 3 and minus 4 4 and 4. That is my matrix A. So first, now for here I'm going to first find the determinant of this one by using copy method. Okay, so the determinant of A is, first write the actual matrix, and then I'm going to write the first 2 columns. So 3 minus 4, 0 minus 4 plus 4. Okay, so 3 into 4 into 4 is minus 48, so that would be 0, the second corner, because there's a 0 there. 2 3 into 4 is plus 24, minus the first corner would be 0 because there's 0. 3 minus 3 into 4 is minus 36. 2 into 4 is 8. 8 into 4 is 32 and plus 32. So minus 48 plus 24 is minus 24. Minus 36 plus 32 is minus 4. So that would be plus 4, and determinant is minus 20. So now I'm going to find the adjoint of these matrices. So just I am writing by hiding the column and the row which our number is belongs to. So you have to be very careful while writing this adjoint, this cofactor. Okay, and with a sign. The signs must be very important. So now I'm writing for the second row. So this is for minus 4. And for minus 3 is 3, 0, minus 4 and 4. Okay, for the last row, for minus 4 is 0, 2, minus 4, minus 3. And for the 4 is 3, 2, 3 and minus 3. And the last 4 will be 3, 0, 3 minus 4. Yes. And now I'm writing the signs. Plus, minus, and plus. Yes. So writing the big brackets. Now I'm going to find the values. Minus 4 into minus 16 minus 12 is minus 4. Okay, you can write this like this, or you can write another step like doing the addition or the subtraction of these cofactors, and you can do, if you can do by your mind, it would be convenient. Okay, that would be practice. How much you are practicing, you will find very convenient and very easy methods. Okay, so for the fifth one, it is 20, and sixth one is 3 into 4 is 12 minus 12. So that is 0. 4 into 8 is minus 8, and 3 minus 9 minus 6. So that is 15, and minus 15 into minus plus 15. So next one is minus 12 into plus minus 12. So this is our cofactors, and the adjoint would be the transpose. So now I'm going to write it in normal way, that 1 over determinant minus 20, and the adjoint would be minus 4, 0, minus 4 as a column, and 8, 20, minus 12 as second column, and minus 8, 15 and minus 12 is our third column. So multiply those every element by minus 1 over 20. So first one is 1 over 5, minus 2 over 5 and minus 2 over 5, and 0, minus 1 and 3 by 5, and last one is 1 by 5 plus 3 by 5 and plus 3 by 5. Yes, this is the inverse of A. So for finding those A's, you can use the method to find the correct answers.